Hi everyone. In this video, we are going to look at how to do some geometries. First one is perimeter. Basically, perimeter represents the total length of a shape. So regardless what shape you have, just add them all together. For example, this one, we have a four-sided figure. We want to find out the total length, the perimeter. So perimeter equals, just add this four sides length together. They are all in yards. 8 plus 6 plus 10 plus 5. Say this is 14, this is 15, so 29. And don't forget the units. So 29 yards. It's very straightforward. But the requirement is that we find the perimeter in yards, so we get it, and then in feet. So what do we do now? You don't have to convert each of these to feet and add them together again. You just convert this final answer from yard to feet. So let's do that. So perimeter equals 29 yards. Still remember how to do unit conversions. We did that from the last video. So basically you use dimensional analysis method in which you just try to have another unit on the bottom so that you can cancel the given unit. So we have yard on the bottom, we want to have feet. So that's the setup. Now the conversion factor between these two is that 1 yard equals 12 feet. Cancelled. Now we need 29 times 12. So let's do that. 29 times 12, 348. So 348 feet. So that's our first example. Now we have another one. So again, in this one, we find the meter in feet because we are given feet. All of these numbers are in feet, and then in yards. So the purpose of this example is that we want not only be able to find the perimeter, we also want to be able to do all of the conversions. This time we go from feet to yards. So first perimeter in feet, we just add them all together. Let's start with 5. 5 plus 2 plus 4, 5, 2, 4, 9, 4, 3. And plus 9 plus 4 plus 3. Let's see what we get. This 3 give us 10. So that's 10. And this, and this. That's 12, 17. So totally 27 feet. Now we also need to answer this question in yards. So we want to convert this 20 feet to yards. So start with 27 feet, multiply by the conversion factor. So feet on the bottom, yard on the top, so that we can cancel feet. 1 yard, 12 feet. This time, 1 yard, 3 feet. This time, feet this is 3. So this time, this is 3 is on the bottom, we divide by that. So 27 times 1 divided by 3, that's 9. So I wrote 9 as the answer actually. So 9 yards. Yeah, that's perimeter. Now let's look at our next topic. This time we look at a circle. So for a circle, the radius is the distance from the center of the circle to the edge. So basically, the size of a circle is solely determined by the radius. The bigger the radius, the bigger the circle, right? And this distance from one side of the edge on the circle to the other side through the center, this is called diameter. This is the radius, and this is diameter. Apparently, the diameter, one diameter equals 2 radius, right? From here to here, that's the radius. From here to here, that's the radius. So in general, diameter equals to 2 radius. Now the formula to calculate the circumference, which represents total length of circle, pretty much like perimeter, but they use this word circumference. So circumference equals 2 times pi times r times the radius. Now you already know 2r is a diameter, right? 2r is diameter. So this formula can also be written as pi times d. D is diameter. This 2r is d. So either one is okay, depend on which one, depend on which is given. If you're given r, use this formula. If you're given d, use this formula. Either way is okay. Now let's find out the perimeter of these two examples here below. The first one, find the circumference. So we are given d apparently. So circumference equals pi times d. Let's use a 3.14 for pi. So this is 3.14 times 12. And let's do that. 3.14 times 12. 37.68. Let's keep 2 decimal digits. They didn't mention that usually when you do your homework, there will be a requirement about to which digit you need to round your final answer. So always pay attention to that. This is just demonstration. So the unit is yards. So total length of this circle is 37.68 yards. Now the next one, we also find the circumference. Apparently, the one that is given is r. So we use this formula, 2 pi r, to find the circumference. So 2 times 3.14 times 4. So let's do that. Two times 3.14 times 4. So we get 25.12. And don't forget the unit, centimeters. So this is the circumference. Next one, we are going to look at how to calculate the area of a circle. Now, let me mention that whenever you deal with a circle or sphere, anything that is round in the formula, no matter you calculate circumference, area, or the volume of a sphere, as long as the shape is round, you will have pi in that formula. The reason is that pi, this number actually occurred in natural world. It's not somebody created. And this number is associated with being round. So no matter what you have, as long as it's round, you will have pi in it in the formula. So now the formula to calculate the area of a circle is pi times r squared. Now pay attention to this the formula. Pi is just a number associated with being round. R is a radius, so radius will determine the size of circle. That's why we have to have in it. The bigger the circle, the bigger the area, right? Y squared, because area is two-dimensional measure. Just like if people ask you, what is how big is your house? Let's say 2,500 square feet, right? Square feet. So area always have this small square here. If this measured in feet, this is going to be square feet. If the radius measured in yards, this is going to be square yards, but always square as unit of area. So again, let's use 3.144 pi. First, we need to find the area of this circle in square yards. So we are given yards, so the result will be square yards. Then we redo the conversion to get square feet. So 3.19 times, pay attention to this. This formula requires to have r in it, radius, and this one given is diameter. So we have to divide this by 2 to get 20. So 20 square. 20 square itself is 400. So we just times this by 400. So let's do that. 1256 looks like. Let's do that. 3.14 times 400. Yeah, 1256. And don't forget the units, square yards. Okay, now we want to convert this to square feet because that's a requirement. So area equals 1256 square yards. Now, using dimensional analysis method, we want to cancel this unit. So we need to have the same unit on the bottom. We want to have square feet in the end. So we put square feet on the other side of this bar. Now, this is a conversion factor between the two units. So 1 square yards, 9 square feet. So we multiply this together because it's on the top. So I just multiply by 9. I still have 1256 on the screen. 11,304 square feet. Yep, that's the area for this circle. Now, next one. So basically, we have same kind of problem, but we need to do conversion again. So we are calculating the area of this circle in centimeter square first, given centimeter, and then we convert it to square millimeters. So basically, same kind of problem. So let's calculate the square centimeter first. Pi r square equals 3.14. By the way, if when you do your homework, if the problem mentioned that use pi equal to 3.14, try to follow that direction. Use pi equal to 3.14. Don't use the full pi. Pi r is 4 square. So let's do that. 3.14 times 4 square. We got 50.24 centimeter square. Okay, now all we need is convert it to millimeter square. So we start with 50.24 centimeter square. Multiply centimeter square on the bottom, millimeter square on the top. One of this equal to 100 millimeters square. Yeah, make sure you put these numbers in the right place. So multiply by 100. Whenever you multiply by 100, basically you move decimal point to the right 2 places. That's easy to do. 5,024 millimeters square. And that's it. That's for the area of a circle. Now we have something very different. And this is very similar to your homework problem. So we want to find the area of this shape, this whole thing inside. Now, certainly we don't have a formula for that because this is an irregular shape. So whenever this happens, you want to use a strategy called divide and conquer, in which you want to split this whole figure into different components so that each component is a regular shape and for which you have a formula. So now, let's say, in this particular case, I want to split this whole figure this way so that you can see I have now I have 2 rectangles. This vertical one from here to here, this green one. So we have a green rectangle here, this one. On the bottom, we have a horizontal one. Let's use a different color. So that's a yellow one. There's another rectangle, right? So we do have a formula to calculate the area of a rectangle. So let's do that. The strategy is that we calculate the area of green one, calculate the area of yellow one, then add them up. So we still get the total area of the whole thing. So the green one, length times width, right? For rectangle area, length times width. Length is 9, width is 4. So that's 9 times 4, 36 square meters, okay, unit. Now let's look at the yellow one. This whole thing is length from here to here, but 8 is only goes from here to here. So we need to add this portion to 8. And this portion is 4. So 8 plus 4, that's 12. So length is 12, and width is still 3. So that's another 36, happens to be the same. So total area, which is our final answer, 36 plus 36, so 72 square meters. Yeah, that's the area. Now next one, the area of a triangle. So the area of triangle, basically the formula is base times height. B is the base, H is the height. But pay attention when you use this formula, there's a requirement for the relation between this base and height. It's not just two letters you plug in there. And these two have to be perpendicular. That means the height has to be on that base. For example, if you use this side as a base, the height has to be perpendicular to this base. Otherwise, you cannot multiply them together. So have to be perpendicular. I want to emphasize that. Now let's do this one. Area equals half times base times height equals half. Base is 14, height is 8. So half of 14 is 7, 7 times 8, 56. So 56 square inches. So this is straightforward. Now our next one is also find the area of this triangle and round to the hundredth place if necessary. When they say if necessary, it means for this particular case, hundredth place represents the second decimal digit. In other words, after you do the calculation, if your answer has more than 2 decimal digits, then that's when it is necessary to round it so that you have 2 decimal digits in the end. Now, which one is height? It doesn't look like we are giving height. Now, let me mention that how to identify the height, because height and the base has to be perpendicular. So we already saw the first one on the previous page. If this is the base, and this is going to be the height, right? Height on the base. Sometimes you have different shapes of triangle that make it the height not sitting inside this triangle. Now, let's look at this in a little bit closer to see how they get this height. Basically, in a triangle, any triangle, you have 3 vertices, right? 3 vertices. And one of the 3 sides will be served as the base. So for example, if this is the base, this side is, it can be anyone. It depends on what is given. So if this is our base, apparently you already have 2 vertices on this base. So there's another one that is outside the base. You're always using the one that is outside the base to draw the height onto that base. That's why we have this height here. Now, if we have a right triangle, what happens is this. Say suppose it's a right triangle, right? Suppose we still use this side as the base. Now, how do we get height? Remember, we draw height from the vertex outside the base. So this is the base. This is the vertex outside the base. When we draw a perpendicular line to the base, because the height has to be perpendicular to the base, it happens to be the same as this side. So this can be the height. In other words, in a right triangle, one of this perpendicular side will be the height. The other one will be the base. Now this is a third situation. So if you have a triangle that looks like this, again, we still try to use this one as base, even though anyone is okay. Now, if this is base, again, we draw the height starting from the third vertex, which is this. And it has to be perpendicular to this base. So if this base is horizontal, the other one has to be vertical, right? To be perpendicular. In other words, this is your height. Half times base times height. So from these 3 situations, you can see that height can be inside triangle, can be on the triangle, can be outside triangle. It doesn't matter. As long as the base and height are perpendicular, you can use those 2 numbers to calculate the area of triangle. Now let's solve this. Area equals to half times base times height. Apparently this one is perpendicular to this side. So we can use this side as base and 3.5 yards the height. So half times 8 times 3.5. This is 4. 4 times 3.5 should be 14. So 4 times 3.5. Yeah, 14. So we get 14 square yards. Yeah, we just finished it. 14 square yards. Now next one, find the area. Now, if you look at it, we can use, actually this is a trapezoid, but we have not learned, at least in this video, we have not learned the formula to calculate the area of a trapezoid. We pretend we don't know that formula, so we are going to take another approach. So pretty much like that divide and conquer thing, we want to do it again. So this whole thing, if you look at this four-sided figure, if you split this figure along this dashed line to the left, you have a rectangle. Then we know length times width, right? We can calculate the area of this rectangle. On the right-hand side is triangle. We just learned how to do that. So we are going to calculate the area of rectangle, then the area of the triangle, then add them up. After we learn the formula for trapezoid, we're going to redo this again to see if we get the same answer. Okay, rectangle. Let me use this symbol. Area equals length times width. 26, I almost made that mistake. 37 is from here to here. This is our length. 26 times 18. So let's do the calculation. 6 times 18. 468. So 468 square meters. Now triangle. Since this is right triangle, this is the base, this is the height. So triangle equals half times base. Now what is base? We need this length, right? The whole thing is 37, and this part is 36. So 37 minus 26. I said 36, did I? So we use 37 times 20 minus 26. That's our base, 37 minus 26. And the height is 18, so times 18. Now let's do the calculation. Half times, this is 11 times 18. 18. Half of 18 is 9. 9 times 11, that's 99 square meters. So the total area, now we want to add them together. The total area equals 468 plus 99. So if this was 100, this is going to be 568. So one less than 100, 567. So 567 square meters. Yeah, this is the final answer. Again, we're going to come back after we learn the formula for trapezoid. Next one. So this is the area of a parallelogram. So what is a parallelogram? Parallelogram is a four-sided figure. You have to have four sides. In this four-sided figure, opposite sides must be parallel. So these two are parallel, these two are parallel. Not only that, they have to be parallel and they have to be equal also in length. So this side equal to this side equal to this. This is a parallelogram. The formula to calculate the area of a parallelogram is base times height. This is pretty much like rectangle length times width, because any parallelogram actually can be converted to a rectangle. Imagine if I cut this off, this triangle, and put it back on this side. What do we get? We get a rectangle with the exact same length, same height. That's why they have same formula actually. They just call them different names for this two in parallelogram. Otherwise, the way we do calculation is the same. So base times height. So let's look at an example here. This one, find the area of parallelogram. Since we know base times height, and height has to be perpendicular to the base, apparently this one can be the base, this one can be the height. In other words, we don't need these two numbers. So area equals base times height equals 50 times 42, 2100 centimeter square. Let's double check. 50 times 42. Yeah, 2100. So So we finished that one. Now trapezoid. This is the formula for trapezoid, and basically similar to base times height. Base times height is except that you have two bases here. You need to add these two together. Again, we don't spend time developing this formula. Half times this two bases, the sum of two bases, and then times height. So now let's look at our example on the next page. And trapezoid is a figure, also four-sided figure, in which you only have one pair of opposite sides parallel. The other pair not. Unlike parallelogram, you have two pairs parallel. Right? But in the trapezoid, you only have one pair of lines parallel. So this is trapezoid. Now we can use that formula, and we need to round our final result to the nth place. So one decimal digit. Area equals half times A plus B. A are two parallel sides, and times height. Height is distance between these two parallel sides. So half times 10 plus 20.8 times 7. So let's do that. Times this is 30.8 times 7. So I have to use the calculator. So I'm going to multiply these two numbers together and then divide it by 2. 30.8 times 7 divided by 2. 107.8. So the rest are zeros since we need to have one decimal digit. So this is our one decimal digit. And the unit is square meters. Yeah, very straightforward. Now let's go back to recalculate the other one, this one. So we know this is a trapezoid because you have four-sided figures and one pair of the opposite lines are parallel. Say the other one not. So this one is parallel trapezoid. We can use the trapezoid formula. Let's do it again to see if my the original answer 567. So half times A plus B times H. Half times AB represents the length of two parallel sides. So 26 and 37. Times height. Height is distance in between, which is 18. So 18 divided by 2, that's 9. So basically, we are going to use 9. 36 plus 26. 26 plus 37. Let's use our calculator. So 9 times parentheses 26 plus 37. Yeah, everything is right. Equals 567. It's supposed to be the same. So we just got the exact same answer, right? Okay, let's continue. The next one is volume. So we're going to look at several different figures. The first one is called the volume formula for a rectangular solid. Rectangular solid is just another name for box or tank in that shape. So you have 3 dimensions. For any volume formula, you will have 3 dimensions. So like this one, you have length, you have width, you have height. Each one measured in the unit of length, right? For example, if this is in feet, this is in feet, this is in feet, feet times feet times feet, that's cubic feet. Cubic, that's 3 dimensions, right? That's volume. So now let's look at our next example. Find the volume, round to the 100th place. So we need 2 decimal digits for this one. And this is the one that I put it out from your homework section on the Blackboard. So you may see a very similar one because all of your questions are from my question pool. You may not get the exact one, but it should be very similar. Now we want to calculate volume of this figure round to 2 decimal digit place. Now the problem is that we don't have exact shape. We don't have a formula for this exact shape, right? So what do? Divide and conquer, always. You divide the whole thing into different components so that each component is a regular shape so that you have a formula for it. Now, basically, this one is that you have a box on the top, smaller one, you have another box on the bottom. Let me draw that. Let me get my ruler. to help you to see the shape. Let's see if I can draw it. I try my best. This one. Yeah, looks okay. Also, this side has to be parallel. Again, I try my best. And this side has to be parallel too. Yeah, looks good. Yeah, you can see we have a box on the top. We have another flat box on the bottom. So each one we can use length times width times height, right? So let's say top portion, top box, length times width times height. Let's make sure we get numbers right. Length, width, height. The length is the same. This is 1.7 is length. Width, this is width. That's the same as this. So width is 3. How about height? Height is from here to here. This 1.7 given is from here to here. So we need to use this whole thing, subtract this portion to get the height. And this portion is given 1.3. So the height here is 1.7 minus 1.3 is 0.4. So we get 1.7 times 3 times 1.7 minus 1.3. So 1.7 times 3 times 0.4. So let's do the calculation. 1.7 times 3 times 0.4. 2.04. Exact 2 digits because we are required to have 2 digits. So cubic meters, this is the volume. Now let's look at the bottom one. Bottom box. Same thing, length times width times height, right? So width is 3, length is 3, and width is also 3, and height is 1.3. So that 3 times 3 times 1.3. Yeah, that's right. 11.70 cubic meters. Now the total is, I will just add them together. 2.04 add to 11.7. Let's see, I just add 2.04 to it. So 13.74 cubic meters. That's it. And just be careful to use that sleep and divide and conquer strategy. Now next one, we just have 2 more. Next one is a volume for a cylinder. Cylinder basically is just, everyone knows what cylinder is, right? The formula is pi r squared h. You see, anything that has the shape of round will have pi in it. The base of cylinder is a circle, apparently. The circle. Now you can view a cylinder as a flat circle growing bigger and bigger in the vertical direction, getting thicker and thicker, so you get a cylinder. That's why you start with a circle, pi r squared. Apparently this is the circle area, base area, and it grows taller, you get a cylinder times height. The bigger the height, the bigger the cylinder, right? Okay, now our example below, find the volume of the cylinder, use pi equal to 3.14, round to the whole number. So let's do that. Volume is equal pi r squared times h. And this formula makes sense too. R measured as length, so like foot, so it's going to be foot square. Height is also length, not foot cube, and that's volume. So 3.14 times. Be careful when you plug in numbers. 20 given as diameter. This formula requires radius, half of it. So that's 10 squared. and then times h, which is 9. So let's do the calculation. 3.14 times 10 squared and times 9. That's whole number. We need to round to the whole number, right? We happen to get a whole number, so we don't need to do rounding. That's volume cubic yards. Yeah, that's the formula demonstration for cylinder. This is the last one. Now we look at the formula for the volume of a cone. This is a cone. Now I have a cylinder beside it, right? Now let's look at why we have this. You can see from inside, there's a cone inside. So there's a base, which is circle. Look at this cone inside the cylinder. Apparently, they share the same circle as the base, and the cone and the cylinder also have the same height, right? So basically, they share everything, same base, same height. So as a reasonable result, the formula to calculate the volume of a cone has to be very similar to that a formula to calculate the volume of cylinder, right? Just in order to be reasonable. So as a result, actually it's very similar. If you do this part pi r square h, that's the formula for the volume of the whole cylinder. And the volume for the cone is 1/3 of it. This is always true and it's proven. So now let's look at this particular example here. Find the volume of the cone using pi equal to 3.14 round to the 10th place. So let's do that. It's a straightforward calculation. 1/3 of pi r square h. 1/3, 3.14. R is 7. So times 7 squared. And the height is 10. So let's do the calculation. I'm going to do this part first and then divide by 3 to get 1/3 of it. 3.14 times 7 squared times 10. Then divided by 3. So I got a 512.86 minus 6. The requirement is that we round it to the 10th place, which is just 1 decimal digit. So this is our decimal digit. We look at the digit to the right. Since this one is bigger than 5, we round this up. So final answer is 512.9 cubic meters. Yeah, don't forget the unit, always carry unit for any measurement. And that's this video, and see you guys in the next video.